everyone, it's me again. My name is Van Folk and I'm 9 years old. Today I'm gonna review something. Do you know what it is? This is a present from Mrs. Tam when I passed a test and I got a certificate, but it wasn't here yet. So, hi Mrs. Tam, I'm really happy to receive this present from you. I will work much more harder to receive more presents from you. Okay, so let's open and see what it is. It's actually a book. I wonder what book it is. So let's open this. Oh, this is so hard. Wow! Just what I wanted. I love it. Wow, this thing is big. Huge. Wow. It is how things work today. Just what I choose. Wow, that is so cool, everybody. Look, it's ginormous. So today I'm going to read this book. Cool. Wow, it's really beautiful, everybody. It's a Scientific American. How things work today. Whoa. It's beautiful. Let's see. So let's read this book. The urban and domestic environment. Technology surrounds us in our everyday lives. Wait a minute, can I get a computer if I don't know how to read a book? Oh, where is it? Oh, there it is. Look, right here, everybody. Just gonna get that. So I'm gonna use this computer and go on Cambridge to see when I got it wrong. I can fix it to see. Failure. Turning on. So let's continue reading. The modern city and the comfortable home are packed with devices that we are all too often take for granted. How many of us know how a microwave oven works? Or give a thought to the maze of service pipes and tunnels that riddle the ground beneath our feet. Yet without these devices, our lives would be far less comfortable and more difficult. This chapter explores how the I don't know that word. I just need to wait because my mom do a password and we need to solve it to open it. So I'm gonna turn it on Cambridge. Mom is on the computer. Turn it off. Turn the Cambridge on. Okay. Dictionary T. 03. Dictionary. What? I forgot. Okay, so the word is infrastructure.
Infrastructure.
Infrastructure and install services of cities have been reshaped by technological innovations and reveals the ingenuity that has created and improved the domestic appliances we all rely on. Let's read the book Skyscrapers. The manufacture of stronger, lighter steel combined with the development of lifts that could carry people safely made possible the first high-rise buildings in 1880s. By the year 2000, improvements in technology and design brought skyscrapers to almost 460 meters, about 1,500 feet in height, with the promises of even taller megastructures using superframes in the near future. Wow, that's so cool. There's gonna be high buildings now in our city. Yeah, some city can have like a company, and it can like company buildings are often really high. Skyscrapers. A skyscraper needs to be strong, stable, and able to withstand natural forces, such as wind and earth tremors. The weight of the building is carried by the foundation, which are set firmly in soil or rock bed. Types of foundation include spread footings, which spread the weight of the building over a wide area, and casing piles, which transmits the load to stable bedrock. Above ground, a skyscraper is constructed around a frame made of steel or concrete, which bears the load of walls, roof, and floors, and so supports the building. The design of skyscrapers has evolved to make them taller or lighter or more specifically geared to the conditions in the local environment. The steel frames of the early skyscrapers in Chicago and New York were followed in cities throughout the world by frames attached by cables to ensure concrete core. Many modern skyscrapers, such as the Hong Kong Bank and the World Trade Center in New York, are built around the steel frame tube design in which the load is borne by steel columns. This book is kind of long, and I wonder, what's this? It's actually so long. You can't believe this. Wow. They are telling us how we can make this thing and how it work. Wow. This is so ordinary. Just like go and go. Look. Wow, space. So I think there's also chapters 2. This chapter 7, this chapter 8. But technology is so much cool. I wonder where it stopped, because technology keep going on and going on. The washing machine, cool. Starts a microwave. Yeah, that's right. And sometimes we also use the vacuum cleaners, yeah. But sometimes some of them can be different. What? The chapter 2? It's so long. Water. That could be so long, everybody. Have you ever seen any people robots like your assistant, Siri, on your iPod? Woo. But you know that thing, there's also technology too. Yeah, technology, that's so cool. So, let's see. Okay, frames. Skyscraper frames provide the main structural supports for the building and are composed of, it's about 45 pages. You can't believe it. You can't believe it. It's so much long. Look from here. See? So much long. This is only chapter 2, but we need to read several. In this, you can study about technology a lot, because I wonder what will be inside something, the technology, like inside the computer or inside the flame, inside the thing. I just wanted to know, but I can't. So one day I tried to do this. I tried to know what the thing is. I studied a lot for it. I should deserve to know it, right? Like I really want to know it. It's so much cool. Put that thing away. Okay, so skyscraper frames provide a main structural support building, and they're composed of materials that are designed to withstand the force of the wind. Although there are many variations. Most frames fall into two categories: skeleton and cable hung. Skeleton skyscrapers, which include steel frame tube designs, use a structural frame to support the walls and floors. And the support is provided by a central concrete core, which acts as a windbreak and as a shaft for lifts and other utilities. Wow, this is the Hong Kong Bank. That is so cool. Whoa, it's big with elevators and stuff. Yeah, I wonder what this thing is. Lift. You just lift. That does look like a lift. Just like lifting us up. That's so ordinary. Have you ever seen things like that? That would be so much popular if you see that. Because sometimes you don't maybe see that thing. Yeah, it's good to look at. Under the city, what will it be like? That would be so cool. Oh, yeah. Beneath the streets, you wonder what's going underway, like a train going underground. Do you wonder what it will be was? You are going to study it now. From the steam heating pipes under Meriden to inner mail strands of London, the systems that keep cities working go largely unnoticed unless they fail. Busy city streets are labyrinthine networks of pipes, cables, ducts, and tunnels. They supply the city with water, electricity, and gas, transport its people, remove their waste, and connect them with the rest of the world. Cool. Beneath the streets of any modern city is a treacherous maze of hidden service systems. Wow, I wonder if a city has that too. Yeah, connecting every building on every block. Such intricate networks are relatively modern phenomenon. Numbers of people flooding into urban areas put enormous strain on the service systems already in place. Substandard water supply and sewage systems gave rise to cholera epidemics that killed millions of people. In the interest of public health, treated drinking water was supplied to the cities in dedicated pipes. Sewers were closed over and kept apart from the fresh water. During the 20th century, telecommunications, electricity, gas, and underground transport okay, just nothing. Yeah. Is that electricity, gas, and underground transport networks have revolutionized modern city life and have increased the complexity of the networks below street level. These service systems are managed by the dedicated bodies responsible for the maintenance and improvement of each system. Yeah. Wow, just the mere 200 feet. That's so popular. Ooh, the bedrock. The sea woman's the bedrock. I can see waterman's pipes is underground. Yeah, that's right. The water. What's up that tall? Steam pipe. The electricity cables. That's so cool. Lift and I always want to know what a lift looks like. Yeah, that's right. That's some of the lifts I usually go on. Lifting is up. Some lifts go up and some lifts like just carry you up all the way. I see that at supermarkets. And it's freaking so cool because I see it. You see? Wow. There's buildings and cars. And just a little small thing. Like something really tall, but I don't really know what it is. Traffic lights inside it. Yeah, inside the car. Cool. I wonder what driving a car will be. Wow. You can read this after I finish my reading, okay? Then you need to give me medical. Okay, promise. And also, let's continue. Population continues to grow in cities, demanding even more reliable fresh water supplies. This demand has led to ambitious engineering projects such as New York City Water. But if I think it's a better cause it must be dream super fast. Okay. Now 10 kilometers, 6 miles tunnel bored through bedrock at 74 meters, 250 to 800 feet below ground, which was inaugurated in 1998. Oh, okay, that's cool. That's actually really cool. I accepted that. No problem. Okay. So, peaks. The term peak once referred to a bundle of rocks or litter sent down a pipe to clean it. Peaks are now sophisticated pipeline tools, specifically adapted for particular attacks and used by service companies to maintain the soundness of their pipelines. Using a range of onboard technologies, pigs can detect leaks, scan for defects in the pipe, make 3D maps of a pipeline, or simply clean the pipe and clear obstructions. That is actually so much cool. I love it. Okay. So cool. Oh, less than escalators. I always want to know that. We will do it now. The first passenger lift was installed in the Harwood Department Store in New York City, USA in 1857. It was designed by Alice Gacciardis and was driven by steam power. Improvements in lift technology gave architects the opportunity to design increasingly tall buildings, contributing to the rise of the skyscraper. Escalators, also developed during the late 19th century, allowed better access to airports, underground stations, and department stores. Over 2 million lifts carry people and freight up and down buildings worldwide. A fifth of them are located in North America alone, where 350 million people ride on lifts each day. What? For real? That's true. Yeah. Okay. That's so much people. Somebody just like one list can carry 350 million people. No, that's just how much they go on the lift, not how much the lift can lift them up. Okay? Okay, you know that. Okay. That's so cool. Now, nearly all this derive power from two kinds of electric traction. Gearless traction elevators can reach speeds for up to 600 meters, 2,000 feet per minute, and are generally used in offices of more than 10 stories and in apartment buildings of more than 3 stories. Gearless traction lifts, equipped with a reduction gear that slows the sheep or purley, move at a quarter that speed. Lifts at a hydraulically driven travel at about 3 meters, 100 feet per minute, and at about as industrial freight lifts on a low-rise office or apartment building of 6 stories or less. An escalator is a people conveyance in which drive chains powered by a high-speed electric motor carry a series of metal staircases can be reversed to carry people upwards or downwards. The first escalators were installed in New York City and Paris, France in 1900. They resembled what we would call a travelator, a smooth incline with no falling steps. Handrails were added later and a modern escalator appeared. Handrails were added later, and in the modern escalator appeared in 1921. Escalators typically run at a speed of 45 meters, 150 feet per minute, and can transport as many as 10,000 people an hour. Wow! Absolutely good. Let's continue. Lifts. Lifts transport passengers can vertically in fireproof cars. Before the lifts can move, both sets of doctors on the car and on the floor must properly close. The drive sheave on a voice machine. Phew. I sure have put this here and want to turn off. And raises or lowers the car to desired floor, a concrete counterbalance floor. Oh yes, counterbalance roughly equal in weight to the empty car plus 40% of the car's maximum load. Counterbalances the weight of the car, effectively reducing the load that the motor has to lift or lower. The illustration shows a gearless traction lift with a drive sheave attached directly to the hoist cables. This system is used for proper express lifts and double-deck lifts in high-rise buildings such as the Empire State Building in New York City, USA. Wow, so much cool! Yeah, it is. You know, that's so cool. I wonder Zazzlers can take about 8 people once a time. Now, underground stations. Now, an underground station. What can it be? Now, an underground and the stations that serves and presents major challenges for oxygens and engineers, since many of the stations and much of the track must be constructed underground without disrupting life in the city streets above. This is done by sinking deeper vertical shafts into the ground and excavating horizontally beneath existing buildings. Shallow tunnels are constructed by the cut-cover method, which involves digging an open trench, reinforcing the sides, then adding on a rooftop to speed up transit times through large underground stations. Many networks and in deep stations, heavy-duty escalators such as stacked in several flights ferry people between the trench and the streets. Ooh, now we're gonna study about tunnels. Yeah, tunnels are dark. We go in somewhere still road, but throughout the tunnel. See, that's so cool. There's something go after the tunnel. It revealed, but inside can be really dark. Some tunnels are not really big enough for big trucks. So I'm really tired to read now, but thanks Mr. Sam for this book. So bye-bye and see you later.